The question says the diagram above shows some of the equipotentials in a plane perpendicular to two parallel charged metal cylinders. The potential of each line is labeled. As you can see, the potential of each equipotential surface is labeled. The left cylinder is charged positively. So your left cylinder is charged positively, right? So what is the sign of the charge of the other cylinder, right? So we have to find the sign of the charge on the other cylinder. See friends, as you can see in this diagram, right, the potential is increasing like this: my 10 volt, 0 volt, minus 10 volt and minus 20 volt. So we can say potential is decreasing in this direction, right? In this direction our potential, right, in this direction our potential is decreasing, right? And we know that the direction of electric field, and we can find the direction of electric field from the potential direction, right? Potential tendency of potential direction. What? Potential decreases, the concept is potential decreases in the direction of electric field, right? Potential decreases in the direction of electric field, or we can say it's in reverse way. In the direction of electric field potential decreases, or if we say it in another way, we can say potential decrease, the potential will decrease in the direction of electric field. So as we can see, potential is decreasing going outward direction, right? So our electric field will be also in this direction, right? So our electric field will be also in this direction. Why? Because in the direction of electric field potential decreases, right? So our direction of electric field will be outward direction, right? And we know for the direction to be outward, this metal cylinder should be your positively charged, right? We know from a positive charge electric field lines goes outward, right? And on a negative charge electric field lines terminates. Clear? So for the first part we can say the sign of right cylinder will be your positively charged, right? Clear? Let us see its next question. The next question is, on the diagram above sketch the lines to describe the electric field produced by the charged cylinder, right? See what we can do. We know that electric field lines is always perpendicular to equipotential surface, right? We know electric field lines is always perpendicular to the equipotential surface. So what we can do, we have to sketch the electric field lines, right? So we can sketch it like this. Equipotential surface should be perpendicular to the electric field direction also. See, so we can sketch it like this. Since this is positively charged, so electric field line will be outward direction, right? Kind of this. Electric field lines should be perpendicular to equipotential surface. So our second question is completed. Now determine the potential difference VA minus VB, right? It's so simple. So VA minus VB, please see, VA is minus 20 volt, VA is minus 20 volt, minus VB is minus of 10 volt, right? So its answer will be minus 20 plus 10 volt, that is equal to minus 10 volt, correct? This is your part C. This is your part C. Now see the last part, that is the part D. Okay, how much work is done by the field if a charge of 0.5 coulomb is moved from along a path from A to E, right? From A to E. Please see, this is your surface A, right? And we have to move from A to E, right? A, then E, then point D. So how much work will be done by the field force, right? By the field force. As we know, the work done, see, there is a formula, work done from point 2 to 1. If any charge move from point 2 to 1, right? So its formula will be, work done will be Q into V2 minus V1. This work done is by your field force, right? If you have to find the work done due to field force, you have to apply this formula, point 2 to 1. If any charge moves from point 2 to 1, so you have to apply formula Q into V2 minus V1. And as we know that the electric field is a conservative field, right? Electric field is a conservative field, so its work done depends on initial and final position. It doesn't matter how it goes, right? A to E, then D, right? We have to actually find work done from A to E, then D. It will be same as work done A to D, initial to final. It doesn't matter it goes via E or via V or via C, anything, right? So it will be work done due to A to D. So it will be Q into our charge is going from A to D. So it will be VA, right, minus VD. As you can see in this formula, 0.2 to 1. So it will be 2 minus 1. V2. So please put the values, you will get your answer. So this will be, please see, this will be Q. What is the Q? Q is 0.5. So this will be 0.5 into VA. VA is your minus 20 volt, right? Minus VD. VD is your 10 volt. VD is, let me check. Yes, VD is your 10 volt. So this will be 0.5 into minus 30, right? So you will get minus 15 joule. So this is the answer of D part. So work done will be minus 15 joule, and this is the work done by the field force. If you have to find work done due to applied force, so you have to simply change its sign, right? If you have to find work done due to applied force, right? If you have to find work done due to applied force, you have to simply do the negative of this answer, that is plus 15 joule. I hope you understand this question. Thanks for watching.